let me take the liberty of actually telling you that you are our in-house expert. Let me just tell you that. What we're going to do right now for all our viewers who are joining in right now, we've done that in the past, and no one better than Srijan to really explain what does this really mean, beyond the fact that undoubtedly this is a landmark, a victory for a country like ours, comes just about few months after after Chandrayaan 3. As far as Aditya L1 is concerned, like always, our guest Srijan has got the model, viewers. Nowhere else you would get a better understanding of what this essentially means. Srijan, let's start. It's the final orbit that it has reached. Over the next 5 years, the observation continues. Why don't you help us understand the objectives? And if it meets those objectives, what does it essentially mean for space exploration?
Right. So today what has happened is that after a long journey of 15 lakh kilometers, we reached an imaginary point. It's called L1. Now that's significant because you don't have a surface to land. There's no place which you can say this is where you're going, or when you're going Mangalyaan, you know that there is Mangal, there is the Mars, you can see the planet. Without any reference, you are in deep space, you are in space where there's nothing else, and you reach an imaginary point. This is L1. And we all know now that L1 is basically a point where the gravity of Earth and Sun counterbalance each other. So with minimal amount of fuel expense, you can keep orbiting this point. You don't really go in stationary, stable yourself at that point. It's not that point. You go around in an orbit. And this is a very big orbit. It takes 177 days to complete one orbit around the L1 point. Now, L1 is between Sun and Earth, which means L1 is also moving. Okay. With the Earth moving around the Sun. So that's why in our system, we have to continuously stabilize our Aditya L1. For that, we have onboard fuel, we have motors, we have a thruster as well, which came into action today. It established, so till now we were going towards the Sun. Now what we've done is that we've started going around this point. Okay.
Can we, with the help of this, so this is a scaled down model of Aditya.
So Aditya L1 is actually 3 feet. Okay. This is a much scaled down model, 3 feet by 3 feet by 2 feet. But this is of course in a few inches. But what we'll do now is, using this model, we'll do two things. One is we'll know what it is doing, and then we'll also go on why it is doing. Right? So let's begin with the biggest component, which you can see here, this top portion, which you can see. It is called the VELC. Basically, it deals with the visible emissions. Now, where are they happening? In the corona. And the corona is the most important part of the Sun because it is the outer layer which you only see when there is a solar eclipse. But that corona is extremely hot, 15 lakh centigrade, compared to the rest of the Sun, which is about 4,000 or 5,000 degrees centigrade. So we don't know why corona, which is the outer layer, is far hotter than the inner layer, which sort of is counterintuitive. We want to analyze that. So it will study solar corona, and it will study also what we have talking since day, the corona mass ejections, which is the most dangerous thing the Sun does, where 1 billion tons of plasma and ions can be pumped towards the Earth, and if it hits the Earth, unfortunately, it can be catastrophic, especially in a society where we are, from airplanes to mobile phones, are all electronic and we're fried. So we need to study and establish a detection system. Fortunately, it will take 18 hours for CME, or corona mass ejection, to reach from Sun to Earth. So if we can establish Aditya L1 as an early warning station, we will have an 18-hour time to react to it. The second component which you see is this green component. This is what the Chair Minister was talking about, SOOT. This is the SOOT instrument. We all know, when we have discussed about the UV radiations from Sun, we talk about sunscreens stopping your UVA and UVB radiations. Now, Earth has ozone, so we are more or less all ultraviolet radiations are sort of taken care of in the ozone layer. They absorb it. But if you go in the space, the space around Sun is filled with UV radiations coming from Sun, which are a major signature of what Sun is doing. The whole idea is to predict what Sun will do. So this suit will essentially analyze the UV radiations from the Sun. The other component, there are two tiny black dots you can see. I hope you can see this, otherwise I'll just point it out to you. There's one, and there is one. This one is more visible, right? What these two instruments do are essentially doing X-ray analysis of the Sun. The Sun is continuously ejecting a lot of X-ray, and through this X-ray, a lot of energy is coming out of the Sun, and that happens to any star. We are very protected, because if that X-ray came to us, we'll be all done, finished. But we have something called the magnetic core, which builds a magnetic field around the Earth. So the X-ray is just reflected back into the space. Doesn't happen when you are away from Earth. So we are going to analyze, that's why you need a space laboratory and not an Earth station. So you analyze X-rays from the sun, which will give its energy signatures. This device is called PAPA, P-A-P-A, this white one. It doesn't mean it's the father of everything, but PAPA stands for plasma analyzer. So aspects, which will analyze aspects and plasma and PAPA will be all here, and they will analyze the plasma of the sun. The sun is essentially so hot that ions, which are charged particles, squish together into plasma. And that plasma is also important because it may come towards the Earth. It determines the sun's weather. So all that will analyze by PAPA. So we all know that sun also ejects a lot of magnetic radiation. Solar flares are an example of it. Those magnetic radiations have to be studied, and this is the magnetometer. This will come out. So now it would have come out. The solar panels, these are solar panels. They would also come out. They will do some energy for the rest of the instruments. The instrument will operate using this energy, and this will come out and study the magnetic influence of the sun. These are actually two composite devices. You can see one here, and you can see one tiny dot here. This one.
Okay,
right?
We'll just
and this one.
Probably just
yeah, if you can zoom it, that'll be useful. Okay.
Let's try closing.
Right. So you can see this one and this one, right? What are they doing is that the sun is full, I told you, filled with ions, positive and negative. These are analyzing the wind patterns of these ions, the solar winds of ions.
So tell me something, Srijan. In terms of solar missions that have been done by various other countries, how is it different for India? Or would you say that in terms of the scope of the mission is way more than what we have seen in the past?
So first of all, this is a 7 labs in one. So this is a 7-in-1 lab. Okay. Nobody does that usually. So this is a Aditya L1 will now become the foremost Earthlings laboratory, the laboratory of humans towards the sun. Right. So of course there have been other missions like the Parker probe, which is going near the sun, which has an entirely different objective. It's going far nearer to the sun, but it wants to analyze what's inside the sun. But in terms of understanding the solar weather, this Aditya L1 is now going to be the best laboratory we have out there by any country, because this is a 7-in-1 lab. The data, the cameras, the analyzers are state of art, the best, because it is also the latest one. And the fact that it is able to analyze 7 parameters together is very crucial, because sometimes, sun is unpredictable. We really don't know much about the sun. We don't know how a corona mass ejection, when it will happen, or when a solar flare happens, or why does the corona, the outer layer of the sun, suddenly increase in temperature. We don't know. And you are analyzing a huge body like the sun from a tiny little window, which is Aditya L1. If an event happens, and we are lucky that an event happens in 5 years, first of all, you have 5 years, which is unlike any other laboratory. So there's a chance that in those 5 years, we might be able to catch the data, and that data will be analyzed across 7 different labs together. I think that composite and longevity and the fact that we have many labs into one makes this very, very special, not just for India, but for humankind.